Hello everyone. Uh, Very late today. I work a lot of work and haven't even eaten. So let's just see if we can get this done. Probably not fast. I mean, it's an old problem. Old problem. A 30, long time ago. You're given a string and an array of strings of the same length. They're of the same length. Return all starting indices of substring S. That is a concatenation of each word in words exactly once, in any order, and without any intervening characters. You're not asking any order. So, you're given string, return all starting indices of substring in S. That is a concatenation of each word. So, 0 bar foo and a full bar. Okay? A word good. So that's no good. Bar foo the. So bar foo the, bar the foo. Bar the foo. Oh, that's permutation. So 0, 1, 2, 3, 4, 5, 6. Foo bar the foo, the foo bar. 10 to the fourth. What do you think? 10 to the fourth. Are 5,000 words. Is all of them concatenated, right? They didn't say they're unique, so they might not be unique. Holy shit. A, something like that. Can we have that? Like, I don't know. Evil. Evil. Yeah, I can see this evil thing happening. Alright, let's see. What can we do? So, 10 to the fourth, that means we can go down, right? But, I mean, okay, so for words a length, so we have word 1, word 2, word 3, okay? Doesn't matter. And then they're all the same length. Then, if I concatenate them together, I know the total length, right? Okay. Then in the S, so we can take the first one. We can examine a counter, which I think will work, but maybe sliding window, if you thought about that. So what do you mean? We do a counter on the words, okay, and then we just, for the first chunk, we will try to see if we can make any match, right? And it's the same length, so maybe I can split based on that. And then try to check if they match. Okay. If they don't match, then we move forward. So move forward, move forward. And as we move forward, things shift inside, right? It shifts inside. Everything gets shifted. You have to try it again. So that will be 10 to the 4th times whatever it costs to split. Total words length. Yeah, total words length. So we have a dummy solution, but it's definitely not a good So we want to find, starting from a certain place, that we have a match, right? And what does that mean? If I was trying to see if is DP gonna work on this? Well, hold on. What we can do, I still feel like sliding window might work. I just need to figure out how it works. But we know if we slide the word's length, then we basically just skip the previous one and get the latter one, right? So we can do jump, right? This, and then we jump forward, and we can keep whatever we have, and then when we jump forward, basically just kick out one and then get another one, and then we can compare. Kick out one, get another one. So that can work for one trip, right? But then we do 30 trips. Because after you do the first and do the second, and it will be the same. So we do one round, we jump, and then we move forward once, we jump, move forward another time, and then when we move forward the whole line, then we don't have to move forward. Let's try. Based on the size, so this might, I don't know, might work. Okay, so I need counter. Right, so I'm going to say words counter will be counter words. And then is n equals len words 0. We always have words, right? Yeah. And then what? We can do some preliminary check, right? We can say n equals len s, and then we say m equals this. So if n is smaller than m times len words, then return this edge case. Otherwise, we do this, and then we are going to jump forward. How do we do that? We need to create the initial, right? So for the start, we can say for start in range, we're going to go from 0 all the way to m, right? We can start from here, start from here, start from here. So if it's 4, 0, 1, 2, 3. We can start from 0. Yeah, because if we say A, B, C, D, we can start 0, 1, 2, 3. We cannot start from 4. So 0, 1, 2, 3, which is right. We start from here. Okay. And then every time we start, we need to build the original counter. So let's say C current C. Yeah, it's just called word C. Current C, let's say, equals counter. Okay. And then when we build a current, we say for I also need the target length. Yeah. Equals this thing. And this is target length, right? So we say for I in range from start, okay, all the way to start plus target length, okay? So if start is 0, target length is 10, right? So we go to 10, right? So if start is 0, target length is 5, then we can do the target length, right? The length, that's the length. So we start to target length. Yes, and then we're going to jump forward by m. Right? That's that. And then we just say currency s from I to I plus m plus equal 1. Right? Because we kind of computing the initial. Blah 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 blah. Once we're done, right? Once we're done, we can have a result. We need a result. This is the initial, and then we say if current C is equal to words C, if the two are the same, right? Then we say rest start append start. Okay, that's the start. And then what do we do? And then, so this is to build the initial, right? So this is the initial target length. And then we're gonna start from start plus target length. No, we're gonna move forward. We're gonna jump forward, right? Jump forward. And then we can do sliding window. So what do? We are going to have a front and a back. We can call it left and right, right? So we say while right, because we can jump forward and then jump forward, we can jump outside, then that's it. That's it. So our right is smaller than n. Okay. Left is going to be what's current right? Left and right. Current left is going to be I. Hold on. We're going to let's move forward. There's a new state, and then we do this. Okay, so left shall be start plus m. because I'll jump forward m. So that's the start. The right is going to be start plus target length plus m. Well, careful. I think it should be -1. Because the length between the right and left. So if this one minus this one, yes, should be target length. So that's the start, right? And we say if right, well, right is smaller than n, which is fine. Then what do? We are going to modify the currency. So we say currency something should be -1. What is something? That's going to be s left minus m to left. Let's see if it's right. So if I'm at 5 and -1, -2, -3. Hold on. So I jump in here. -1, -2, -3, -4. Yes. So if we minus this and to the left, that's what we're gonna give away, and something we're gonna plus equal 1. So that is gonna be right minus m to right, right? Because that's the new thing we just included. So right. Oh, careful. Careful, careful, careful. Right is the actual index, okay? If right is the actual index, so right will end here. If we go 1, 2, 3, I go too far. So that should be -m plus 1, right? Up until right plus 1. That is the new thing. So this is going to be plus equal 1. And then again, we say if current C is equal to world C, then rest dot append. So it's not start. That's going to be append left because that's the starting point, right? And then if not, it's fine. A left plus equal to m and a right plus equal to m. So we both move forward. 1, 2, 3, 4. Yeah, both move forward. And for this one, we are ending here, right? 1, 2, 3, 4. Yes. I mean, we could set right to be outside. That is okay, I suppose. But if we do that, then yeah, I think we can. So just make it easier. So right is outside, and then we have to do smaller equal to. Okay. Right is outside the target. Yeah, but it's, no, I don't like it. It's hard to justify. I'd rather do it this way. Okay, so once we're done, right? Once we are done, we'll go back here and then we'll move 1 forward. And then we redo everything. Eventually we're gonna return rest. Okay, let's try, see if this one works. Okay, so we have some good test cases. This one shall return 0 and 9. This one shall return nothing. And this one shall return 6, 9, and 12. And our ugly, ugly one, extremely ugly one, this one shall return, holy crap, a lot of things returning. Okay, so Alright, this one we change to SN words. Find substring. I should say sorted. You know what? It'll be easier just to sort here. Alright, let's see if we get this one right. Yeah, it should be right. And then I can throw in some, I don't know. Okay, how about A? How about this? You want ugly? This one to me is pretty ugly. Oh, hold on, they're not the same length. Shoot. Not bad. It should be the same length. Otherwise, it will be too ugly. The heck? Okay, try it. 2018, that was a long time ago. Oh, it was my birthday. Oh, we passed. So that does seem to be, oh my god. Look at that. Back when I was very, very green in this one. Yeah, I'm curious. That's 3 years ago. 3 years ago. The whole journey starts back then. And I got it past. I started from 5, past the 8 o'clock. Just kept trying. Did I check the answer? I have no idea. And then I got, CPP. I used CPP back then. Haven't touched this problem since then. And then the next morning I try to do it again. Oh wow. Okay, so that probably is a solution. Hold on, I'm gonna open this one as well. What type of method was I using? Concatenate. Oh wow, I was I was concatenating everything. Oh, and I was doing fine. Oh my god. Yeah, it ain't work, man. 174. That's the original solution I got. Recursive find. Whatever the heck that is, it does pass. That's the good solution. 174. Then we have more. We have 178. So yeah, that's pretty good. Alright, that's pretty good. That's pretty good. Okay, so this is what? 20? 30? Why do people hate this one? Sliding window. The fact that each word has the same length tells us that we only need to do word rounds of sliding window, because after that, we will be repeating previous work. Hence, we pick a starting point, right? Pick a starting point, use counter to match substring to words, to concatenation, to match substring to words, and slide window it, len word steps at a time. Then, once we're done, one round, and move forward one step, and then repeat. So OMN, right, where N is lenets and M is len word. Pretty sure this is the solution. Let's see. What the heck is this? Okay, that's a counter. Yes, that's true. No, I'm not going to read this. We have a solution. Hash table. Sliding window. Huh. Why is it so complicated? Did they not use... They use counter too. I think they try to put everything into one thing. The right goes forward. I'd stick to mine. Because it works. Is it complicated? Maybe a little bit, but overall it's not. Right, so maybe let's put some comments. Well, there's no comment here. Should I put comment before I submit? I just say build the initial counter. Alright, this is the initial counter. And then a sliding window. One word at a time. One len word step at a time. Alright, that's it. I don't have any Ghana for this. Maybe we can read. I kind of get an idea what this one is. You're given a zero-indexed 2D array grid of size n by n. Each cell has one of two values. 0 is an empty, One is the obstacle. May be removed. You can move up, down, left, and right. From and to an empty cell, return the minimal number of obstacles removed, so you can move from the upper left corner to the lower right corner. So this one is 2. Interesting problem. State. Oh, hold on. 10 to the 5th. 10 to the freaking 5th. OMN will work. Okay, this is the grid. We can go without. Oh, wow. Interesting. Man, we can DFS, try to see if we can find a path towards the end, which is easy to write. But we'll hit a point where, let's say, there's no more path, right? Like you're getting stuck. It's like the places you've been before. So if that's the case, then we just give up. But if we cannot move, it's because we got stuck. Then we say we move 1, and then we try to go, and then move another 1. Then we try to go, and then we go back, try to move the other one. Oof, that is not working right. Now, we don't want a shortest path. What we want is a path that passes through minimal number of obstacles. But there are so many ways to do this. So many. Oh. the number of obstacles need to be removed. The minimum number of obstacles need to be removed to reach the target. Like this one will be 0. This is 0. If you start from here, that's 1, because I need to remove this, right? So 1. And this, but we can go 4 directions. That's the thing. We can go 4 directions. We can go 4 directions. Like for this, it depends on this, this, and this, right? Like this. I mean, this one definitely it's easy to do. And then this. What if we have, like, what if we obstruct here, and then we're looking at this, but we can go this way, right? Then you're looking for this, looking for this. Can I reach? And how the minimum number that needed to reach? Yeah, it's a difficult part because it can go 4 directions. Yeah, we can just like it's visited. Yeah, we can do that. Like if it's visited, then we just don't check because that depends on that. Yeah, if we go from here, I guess this one we say 0, and this one, because we can reach without going through, so that's also 0. So I say 0, 0, right? And then for this one, now this one, I can reach here, but it itself, so this one's 1. And for this one, I can reach, like I think I see a 0, so as long as it's something is 0. So initially everyone was set to infinite, right? So once we see a 0, I say, okay, now we know that's smaller than 0, and I say that's just 1. So we have 1. Hold up. Draw it up. 0, 0, 1. This is 1. How about this one? This one's C, so this one's 1 as well, because it sees this is 0, right? So this one's 1. How about this one? No, the way we do, because we're trying to go to the lower right, so I think this is the right order. So we can go this, and then we can try to find this one. And we see this one depends on this and this, right? Yeah, this is 1. These two are certain. So this one is certain. So they can check. They can check. And it will definitely, because no matter how it has to go through these two in order to get here. So this one is certain, and this one, yeah, no matter what, you have to go through. Okay, you can go through this. You have to go through these two, right? You can go through this, but you have to go through this. But you have already done this. So that just means, man, I'm not sure. Because what if we don't have this, right? And now we can go. But yeah, this is deterministic. This one is also deterministic. Wait, is it? Is it deterministic? Well, we're not talking about deterministic. We're talking about whether it's possible. And this one is possible. So yeah, these two are possible. So they become. So the question becomes from here to end up here, and from here to end up here, right? So now for here to end up here, like we can ignore things at the bottom. We shouldn't ignore, right? So the things meeting here is this and this, right? So we know from this, we just need to break one. So yeah, these two are one. And this is also one, okay? So now these become advocates. So we just need to reach this. So for this, it has, so this, it can reach, the thing that can reach it is this can reach it, this can reach it. So this can be 2, right? This can be 2. And for this, we can reach, this can reach. So this one's already set. This one's already set. So these two are not set, which means to reach this one, this one come down, this one come down, which means for this will become 2, and for this will become 2. And for this, the same thing. So this one will become 2 as well. Right, and then we have multiple, then we just keep the smallest count, right? And then the next level is these. And for this, we can reach, so these are done. So the only thing is this one. So this one will become 2. And this one will be 2. And this is already done. So that's why it's 2. But this is just going to be 0. I can reach surrounding. This will be 1, 0. Right, 1 and 0. So next level is this. 0 will be 1, 0. Next level, and next level. And then advocate, and eventually we go back. I think this probably is the solution, but I'm not going to do it today. Save it for tomorrow. Save it for tomorrow. This might be the way. Anyway, I will see you guys tomorrow then. Adios.